I'd like to tell you about 3 things you can change in your lab today to improve the way you do your chemistry. So let's talk about heating and stirring magnetically. You may be familiar with using electric heating mantles. You may be familiar with using hot plates. In my own experience, I've been lucky enough to use good quality hot plates. But what makes a hot plate good quality? And how do you know it's the best one for the job? So let's talk about power. So this here is a Radley's Tech hot plate, and this will heat with 800 watts of power. So in real terms, what that means for you compared to lower wattage hot plates you might be used to using is it will heat with 35% reduction in heat up time. The disc on the top here is what we call a Kera disc. So it's an aluminium disc with a thin ceramic coating. So it's optimizing the heat transfer to whatever you have on the surface. Now, with the Tech model, you have the option to control temperature with a PT1000 probe. So this plugs into the back, and you can either connect that to an aluminium block, which I'm going to show you in a second, or you can control the temperature of the hot plate without an external probe. So that is up to you. Of course, working in a chemistry lab, potentially you're going to have spills, there's potentially going to be gas fumes. So it's important that this unit is hermetically sealed. So the casing is fire resistant, and you will not damage the inside if you get any solvents or vapours on the hot plate itself. Because of the robustness of these hot plates, we would expect them to last you about 10 years. Great cost of ownership. So now that you have a high quality hot plate, what about actually heating your reaction mixture? So like me, you're probably familiar with the pain of using oil baths. Something like this. Now, obviously we didn't fill that with oil because it would have been a disaster. But I can tell you, I've spent quite a lot of my time in the lab cleaning up oil spills. So why would you do that when there's a better option? Like this. So this is a Radley's heat-on block, and obviously what you notice is there's no messy oil. So it's a solid aluminium block, and this sits directly on the hot plate with an adapter which we provide. This one is for a 3-neck round bottom flask, but we do provide them for single neck flasks as well. I talked earlier about the external control with the temperature probe. So this heat-on block has a hole for that probe. So what you'll notice on the hot plate is it's registering the external connection. So what the hot plate is doing is feeding back the temperature from the probe, and I'm heating to the temperature of the block. Monoblocks like this one are available from 250ml all the way up to 5 litre. If you're working at a smaller volume, you can use the multi-well holder with inserts for smaller flasks, such as this one, which is a 100ml size. Also available with inserts for vials. They're simple to clean, using typical solvents you would use in the lab, or of course soap and water. So I've turned the stirring on. So the hot plate has strong magnets, and I turn this up to 800 revolutions per minute. And the way that it works is it will slowly build up that RPM so that your stirrer bar does not decouple from the magnet. So back to the heat-on block, we've obviously talked about not needing any oil. The coating here is a fluoropolymer. Of course, you're working in a chemistry lab, it needs to be chemical resistant. So we've made sure that it is. So we're heating and we're stirring, but what if you want to heat to reflux? You get one of these, right? Water condenser. But what if this is not connected properly? What if your tubing is not secure? What if the water pressure increases when everybody else turns their experiments off? Could end up like this. So now I've dried off, what's the alternative? So how about this, the condenser? What do you notice? No inlet or outlet for any flowing water. So how does it actually work? So this is an air-cooled condenser. Internally, there's a V-glue column. We make this on site in our workshop across the road. Inside, there are indents into the column, so we're increasing the surface area internally. We then encase that glass with a finned aluminium jacket. And in between the jacket and the glass is a small amount of sealed water to act as a heat transfer fluid. So it's easy to attach. Simply goes on the same way a water condenser would. We have two sizes. This is a mini. So if your working volume is half of the 250ml round bottom flask or below, we recommend the mini. If you're working up to 1 litre of solvent, we would recommend the standard. And these are available in a range of joint sizes to fit your needs. So there you go, 3 smart tools that you can change out in your lab today to improve the way you do your chemistry. To find out more information, please visit radleys.com. And if you are in the UK, go to our e-shop to purchase.